Hello everybody, welcome to this video where we continue with the time series forecasting method that methods that I talked about in the previous video. We will go over multiplicative decomposition in this particular video, and here is the example that I'm going to be using. So here is data for a company called Tahoe Salt. Tahoe Salt sells rock salt to retailers in the Tahoe area. And the demand that you see here is demand for bags of rock salt. These are large bags of rock salt. And you see demand for over the last 4 years, you'll notice that we don't have demand for year 1, quarter 1. It starts in year 1, quarter 2. Then we go to year 1, quarter 3, year 1, quarter 4. So it's here by quarter. And but we also have demand for year 4 and quarter 1. So this way we have three pieces of demand for quarter 1, 3 points of demand for quarter 2, 3 points of demand for quarter 3 and quarter 4. I mean, this sort of parity need not exist. And in real life, a lot of times, this sort of parity will not exist. But it's good to have parity so that formulas sort of become easier, right? Now, the idea is for us to predict and forecast the demand for the last 3 quarters of year 4, right? So what's the demand going to be like? Now, before we even actually do the forecasting, the very first step that you should look at is, in the last video, we talked about 3 different things, right? There is level demand, there is trend in the data, and there is seasonality in the data. The question is, do we see that in the data that we have? Now, just looking at these numbers, it's not clear. But the simplest thing that you can do is just make a plot, right? So what I'm going to do is I'm going to choose all my demand data here. I'm going to insert a straight up plot, right? So I'm just going to insert a plot. Let's say a 2D line plot like that. And there you go, right? So this is a plot, and a few things that we clearly see is that there is some sort of seasonality, right? So demand goes up, then goes down, then goes up, then goes down. Not only that, you also see that there is a subtle trend in the data. Demand is definitely going up, right? As the years pass. So as the quarters pass, demand is definitely going up on a continuous basis. So the question is, can we capture so there is trend in the data, there is seasonality in the data, and of course there is level demand also. So can we capture the trend and can we capture the seasonality? And that's what we'll talk about. Now I'm going to delete this chart. This chart is useful to show us that there is trend and seasonality, but let's see how we can capture that with numbers, right? So I'm going to delete this just for the time being. All right. Okay. So because we saw both trend and seasonality in the data, for us to be do any sort of analysis, you know what? Let me insert this chart again. Let's keep it around. Let's keep it around, right? Now, for us to be able to capture seasonality, you'll notice that because there is trend, the presence of trend might skew the seasonality that we have. So to make sure that the presence of trend does not skew our seasonality, the very first thing that we should do is get rid of seasonality in the data. And then we'll capture trend by itself. Then we'll strip trend out of the data, and then we'll capture seasonality, right? So the first step is to capture seasonality. Now, to capture seasonality, there are a couple of ways of doing it. Now, there is a simple way, or the simplest way to do it is to calculate something called the seasonal index. And that's the first thing that we're going to do. We're going to capture something called the seasonal index. Okay. Seasonal index is what we're going to capture. But before we capture seasonal index, there's some sort of number that we calculate. And this I'm going to calculate is called the seasonal factor. Now, the difference between the seasonal factor and the seasonal index is that seasonal factor is something that you will see for every individual data point. Not for every individual data point, but for most of them. But once you calculate a seasonal index, the seasonal index will remain constant for each season. Now, in this data, what are our seasons? Our seasons are obviously based upon the 4 quarters of the financial year, right? First quarter, second quarter, third quarter, fourth quarter. So that gives us 4 seasons in this data. Now, seasonality, the seasons in seasonality can be in anything. If you have 12 months worth of data, each month could be its own season because you might have different demand patterns for each of your different months. Or you could be looking at something where the seasons are days of the week. You have 7 days of data and the same pattern repeats on every day. So you can have 7 days and each day is a season. So the season can, well, mean anything. Now, in this case, it can mean quarters. And the way you deal with seasonality, when you have even number of seasons and when you have odd number of seasons, is slightly different. Odd number of seasons is slightly easier. I'll show you how to deal with it when you have an even number of seasons, and then you can calculate the same. You can do something similar with odd number of seasons. Right? Okay. So the first thing that we need to do is to calculate the seasonal factor. And to calculate the seasonal, we need to do one more thing. So let me not get ahead of myself. So the first step that we are going to do is calculate, what did they call it? Deseasonalized demand, right? So we need to calculate that. For that, we had to calculate a deseasonalized demand. Right? Now, what we are doing here is we are sort of trying to calculate some sort of running average, so that you can look at it more as a linear trend rather than change in your seasons. How do you do that? So to do it, now there are a couple of ways of doing it. The simpler way of doing it is to calculate something called, you just calculate average demand, right? So you just calculate the average value of all your demand. Now, this is not the method that's in the textbook. I'll show you the textbook method in a second, but I'll show you the simpler method first, and then we'll move on to the more accurate and the more useful method next, right? So you calculate an average demand, and then you say that, well, my seasonal factor is just demand divided by average demand, right? Oops, forgot to make that absolute reference. There you go. And there, right? Right. So you'll notice that some of these seasons have a factor where the factor is more than 1. Some of the seasons have factors less than 1. So seasons with factors less than 1 are the ones where demand is less than average, and seasons with factors more than 1 are seasons for which demand is more than average. Now, once you have a seasonal factor, then you can use this to calculate seasonal index and whatnot. Now, this is a simple method. The problem with this is that this is the average for all the data that you have. But remember that there is an increasing trend in data. So this calculating average does not capture that increasing trend in data. Now, that is the reason why we calculate the, instead of calculating seasonal factor directly, we'll calculate deseasonalized data. Now, this deseasonalized data does not mean that we are not going to include trend in the data. So how do you calculate trend, right? And the way you do that is because you have 4 seasons. The first 2 data points, you're not going to have any data in the first 2 data points because you need those numbers to do some calculation. You're not going to have any data in the last 2 data points either. And the number of data points where you don't calculate deseasonalized data is always equal to the number of seasons you have, right? Now, for this here, the way you calculate is you're going to calculate a running average. You're going to say, well, I'm going to calculate an average where I have the current number plus the number, one number before that, one number after that, right? So I have one number before that, one number after that. So I have one data point from season 3. I have one data point from, one data point from season 4, one data point from season 3. I have one data point from season 1. I don't have data point yet from season 2, but we have to keep everything symmetric. So because we have to keep everything symmetric, what you do is you take half the demand for the first season here and take half of the demand of the season here. So this way you take some demand from season 2, some more demand from season 2, and you're adding them together. And the only reason you're doing that is because you want to keep everything symmetric around the current data point, right? So you have the current data point, which is season 4, one data point before that for season 3, one data point after that for season 1. And for season 2, instead of getting a single data point, I'm going to take half of the data point before, half of the data point after, right? So that'll be 0.5 times the demand for quarter 2 plus 0.5 times the demand for quarter 2. Now, as you can see, if you had an odd number of seasons, because you have a middle number here, you'll have the same number above as below. So because that's the case, you don't have to do this 50-50 split at all, right? So if you have odd number of seasons, this calculation becomes easier. Now, you have added numbers for all 4 seasons. So because you're calculating averages, you're going to divide this whole thing by the number of seasons, which is 4, right? So 1 data point for season 3, 1 data point for season 2, 1 data point for season 4, and then 1 data point for season 2, adding 50%, from the 2 ends, right? So that gives me 19,750. Now, this calculation, once I write this formula, I can just copy the formula over. Let's check that this is, we are doing this correctly. So if I check the last number, you'll notice that I get 1 data point here, 1 data point here, 1 data point here. That's blue, red, and purple. Blue, red, and purple. And 50% of green and 50% of magenta, all of that divided by 4, right? So I have the formula written down correctly. Let's check one more. Let's check here, right? So right here. So 1 data point here, 1 data point here, 1 data point here, 50% of green and 50% of magenta, right? And that's what we have. And this is the deseasonalized demand. And this, if you notice, if I look at these numbers, you'll notice that they are continuously increasing, right? So 19,750, 20, 20. I mean, it might not always continuously increase if the trend is pretty small. Some of these might get switched around. So 21,750, 22,500, 22,125. See, this is slightly less than that, but then it goes back up and then goes back up. So in general, this is an increasing trend, and that's what you're trying to capture. You're sort of stripping seasonality out of it, right? By averaging out by the number of seasons. Now, once you have this, now you calculate the seasonal factor and the seasonal index. Okay, let's calculate the seasonal factor first. So seasonal factor is simple. You take the demand divided by the deseasonalized demand. That's the seasonal factor. It's as simple as that. Okay, some of these are less than 1, some of these are more than 1. Now, to calculate a seasonal index, you calculate one seasonal index per season, right? So, seasonal index for quarter 2 will be, you look at all the seasonal factors you have that are related to quarter 2, and then you average them out. How many of them are there? So, this is season 2, right? This is season 2. And you have another one for season 2, and that's it. There are only 2 numbers. So you just average those 2 numbers out. So season 2 plus, this is another one that's season 2, right? So the average of these 2 numbers is your seasonal index. Okay? Now let's do it for season 3. So for season 3, this is for season 4, right? So season 3, this is going to be season 3, season 3, season 3. Right there. So this number plus this number here, right? Divided by 2. Now let's do season 4. So for season 4, this is going to be this number here and this number there. Oops, sorry. This number here plus this number here, that's season 4, right? Divided by 2, and finally this number here plus for season 1. And there you go. So these are my seasonal indices. Now you'll notice that it might not exactly add up to 4, but it'll approximately add up to 4, right? That's because there are 4 seasons. And what you're essentially saying is that if you aggregate demand over all 4 seasons, about half of that demand is in the first quarter, about 68% in the second quarter, for second quarter is 50%, third quarter is 68%, fourth quarter is about 109%, and the first quarter is 168%. That's the, those are the seasonal indices. So once I calculate the seasonal indices, I'm just going to repeat the seasonal indices, right? just going to repeat the same number. So you only calculate one set of seasonal indices, you don't continue. So oops, this is equal to the same number. I'm just going to repeat my numbers. The same 4 numbers that are repeated again and again. All right. So these are my seasonal indices. Right. So once I have my seasonal indices, now what I'm going to do is the next step, once you calculate the seasonal index, is to estimating seasonal factors. Oops. Right. So once you have the seasonal index, now you can calculate level and trend. Right. So let's calculate level and trend. And once you calculate level and trend, we can, we can take it from there. All right. So let's calculate level next. So to calculate level, this is time series data. So I'm just going to call this non-seasonal data. You have deseasonalized data and you have non-seasonal data. So non-seasonal data is just you take demand and you divide that by the seasonal index. Okay. There you go. Take demand, divide by the corresponding seasonal index, you'll get non-seasonal data. Now using this, we'll calculate level and trend. Now level and trend you calculate in a very straightforward fashion by using regression analysis. So level is just the y-intercept and trend is the slope of the line. So if you take this line and you plot this line, the slope of the line is trend and y-intercept is the level, right? So let's do this calculation. So to do this, we say level is the intercept. So intercept, right? So the known y values. So the y values are the non-seasonal data values. And known x's are the periods going from 1 through 12. So x's are the time values. So time values will always be on an increasing trajectory. So that gives you the level, and finally the trend. So trend is the slope, like I said. It's the slope of all the y values and the corresponding periods. Right? There you go. So slope is 669.93 and level is 17,547.27. Now once you have level and trend, now you can use this to forecast for the let's say the next 3 quarters of season 4, right? And how do you do that? Here you'll notice, right? So let's calculate the forecast. So I'm just gonna move this over here because I want to show you something with the chart in a second. So for the next forecast, so this is going to be next 3 time periods, 13, 14, and 15. Those are the 3 time periods for which I want to make a forecast, right? So let's actually do a forecast. So you can also forecast for the previous time periods you already have. You don't have to just forecast for the future. So the way you do the forecast is you say level. So level is the y-intercept plus slope. So level and slope, both of these have to be absolute references. I'm going to make them dollar values. So times the time, right? So level plus trend times the time, that's the equation. But this is not it. For forecast, you have to multiply this whole thing with the corresponding seasonal index, right? And that will give you the final forecast. So the demand was 8,000, but the forecast was 1,117. Now, why is this useful? This is useful not just to tell us that this might have been the forecast, but also because now we can use this to do error analysis, and we'll do that in the next video. But not, let's do a forecast. So I can do a forecast. I can calculate this to level 15. The only difference is that I have to calculate my seasonal indices also, right? So if I repeat my seasonal indices, you'll notice that these are my demand values for the next 3 time periods. So I have my level, I have my trend, I have my seasonal indices. I can use that to make future forecasts. But the farther into the future you go, the worse your forecast is going to get. All right, that's always the case, right? So that's something to keep in mind. And this is it. So this is the multiplicative decomposition method. I know that it took about 20 minutes. This video is already 20 minutes long, so I'm going to stop it here. What we'll do in the next videos, we'll talk about error analysis. How do you analyze the error for this? How do you aggregate the error for this and whatnot? Actually, yes, that's what we'll talk about in the next video. All right. I'll see you all in the next video.